Okay. Good afternoon. Okay. Today we are going to learn about donor membrane equilibrium. Donor membrane equilibrium is a phenomena which explains about the diffusible ions and non-diffusible ions. So what it postulates is that when, if for example this one is a membrane, when a diffusible ions on this side, on the inside of the membrane and the outside of the membrane should be at equilibrium. It postulates that diffusible ions on inside the membrane and outside the membrane should be at equilibrium. It should balance in a way that equilibrium should be reached. This means that, for example, if for example we have sodium ions here and we have chloride ions here, this one inside means it is inside the stomach, right? Outside means it is in the blood. Okay? So these sodium ions, which is inside, should be equivalent to what is outside. Like for example, we should have sodium ions here, and these ions are diffusible. Okay? These ions are diffusible, and therefore an equilibrium must be reached so that this membrane will be equal, it will be at a electrically neutral. So this is now what is going to come to explain about donor membrane equilibrium. For example, if for example we add a polymer, like for example we add like a polymer which we can denote it as R minus in the inside the membrane, and for example we have our sodium is here and chloride is here, and also the sodium and chloride must balance each other. The presence of this polymer affects the absorption or the passage of these ions on the other side of the membrane. Remember, this polymer is non-diffusible. Okay? So it is non-diffusible. So what we are going to say about now, for example, if for example a plain drug is given to a patient, for example, a drug alone can be absorbed around 60%. But in the presence of a polymer, the same drug can be absorbed around about 99%, about 3-fold. Okay? So you can see the importance of polymer, the importance of macromolecules. Now, we are going to derive an equation that is going to explain why drug in presence of polymer is going to be absorbed 3-fold. It's going to be explained by donor membrane equilibrium. So this one is inside and this one is outside. Outside is the blood and the inside is intestine. Now, here we have our polymer. Here we have sodium. Here we have chloride ions. We also have sodium ions and chloride ions. It should balance each other. But now, the concentration of the product of the concentration of these diffusible ions should be equal to the concentration of diffusible ions outside the membrane. Are you getting that one? That the concentration of these diffusible ions, the product of the concentration of this one, of diffusible ions inside the stomach, should be equal to the concentration of these diffusible ions outside the membrane in the blood. Okay. Now, what we are going to say that sodium ions, concentration of the sodium ions inside the we already said about the product, okay, the product, and the chloride ions inside will be equivalent to the concentration of sodium ions outside and concentration of chloride ions outside. Okay, so this one we can say it is going to be equation 1, right? Now, if you look at the inside the membrane, that this sodium ion is going to be equivalent to R, this one, this polymer inside, plus the chloride ions inside. This one, we are going to say equation 2, right? We also have to postulate and say that again, that the sodium ions here should be equivalent to the chloride ions outside. This one is inside, this one is outside. Remember, we are supposed to bring about electroneutrality. That is why we are supposed to balance this thing. So, we are going to substitute equation. This one is equation 3.
Equation 3, right? Sodium oxide is equivalent to chloride oxide. See, electrically, sodium inside is equal to R minus and chlorine plus. Correct. This one is correct.
Yeah.
Sodium inside. Right.
Yeah, this one, sodium inside.
Then you get sodium outside.
Yeah, sodium outside. Yeah. Is equals to chlorine outside. Yeah. This one now is going to be equation 3. So we are going to substitute equation 3 and 2 into equation 1 because it's just the same thing. So sodium, where we have this sodium inside, we are going to this one. No, these ones are just like this. Yeah, sodium inside.
Substitute 2 in 1.
Yeah, we are going to substitute this one. Sodium inside. Sodium inside is going to be R minus inside plus chloride inside, and then this one, the whole of it, chloride inside. Okay, chloride inside is equals to sodium yes.
3, substitute 3 in 1.
Yeah. Three we are going to substitute here. Yeah, this one. Chloride outside into chloride outside. So this one is the equation we come up with. Now, if we multiply this one now, like chloride are inside, you multiply by this one. This parameter is just like, for example, A plus B is equals to C. So you will multiply this one. It's going to be R minus concentration inside, chloride inside, okay, plus chloride inside squared, okay, is equals to chloride outside squared. This is what's going to come up with now. Now, following this equation is like, for example, A plus A over B plus 1 is equals to C over B. Right? So we can just use the same phenomena. This one, we can just substitute the same thing. We just apply the same principle so that we can come up with the equation, the final equation. For example, that R minus chloride.
No. R minus divided by chloride.
No, let me just finish. Minus this one. Then divide by chloride inside plus 1 is equals to chloride outside squared over chloride inside squared. Okay? So this one, this chloride and this chloride one will cancel each other. Okay? So what we come up with is that R inside divided by this chloride inside, because already we have cancelled this one, we remain with one chloride. Okay, plus 1 is equals to this chloride outside. So we can just cumulate it and say that this chloride we can just square it. Okay, that chloride over this chloride inside, then we square it. Okay, then what we are going to come up with is that this one chloride, the concentration of this chloride outside over concentration of chloride inside will be equivalent to the square root of R1 over chloride 1 plus 1 equals to this one. Okay, have you understood up to that point? I think you have followed it very well. Up to this point, I think you got it now. Now, suppose, for example, we said like this, that chloride, we represent it as D, drug, okay? Now, if we substitute this chloride, we will say R, that R inside plus 1 is equals to drag outside over drag inside. Now, if after reaching this place, we have to go back again to what we said initially, that in the presence of a polymer, the drugs will be 3/4 absorbed. Okay, so suppose, for example, we took our polymer as 8, so even the chloride ions will be 8. Like, for example, it's going to be 8 plus 1, the square root is equals to drag outside over drag inside, right? Now this one, what is the square root of 9? This one is 9, okay? The square root of 9 is 3, okay? 3, the square root of 8 plus 1 is 9. So the square root of root 9 is 3. It's going to be drag outside over drag inside. So if we cross multiply, then we get three times. So the drug outside will be 3 times more than the drug inside, right? This is now explaining about absorption of drugs that in presence of a polymer. Like, for example, we took sodium CMC, okay? Like this sodium plus CMC is minus. So in presence of this CMC, which we represented it with R minus, then it means that this drug will be 3 times more effective in presence of a polymer. Suppose, for example, we took, for example, 99. 99 plus 1 is equals to D O over D1. So it means what? 10 will be, this drug will be, this drug outside the membrane. Remember, outside is the blood. What we want to achieve is that this drug is supposed to be absorbed, right? That this drug is almost 10 times more effective, okay, or 99% more effective, that it can be absorbed into bloodstream in presence of a polymer, right? We said initially that without a polymer, this drug will be absorbed like 60%. But in the presence of a polymer, these drugs will be absorbed more than 90%. So this one is explaining about donor membrane equilibrium. Do you have any doubt? Okay, I think if you have any doubt, you can ask me.